Assalamualaikum warahmatullahi wabarakatuh. I am Nushada binti Lezat who represent for this group. Firstly, we are from CDCS 143 and our course group is RCDCS 143 This subject is conducted by Madam Suzanawati binti Abu Hassan. Next, I want to introduce my members who involved for this group project. First, Nurul Aina Nadira binti Azman, Nurin Hidayah binti Rosman, myself Nur Syuhada binti Lizat, and lastly Nur Shariza Akmal binti Razaman. So for this group project, we apply Gauss-Jordan elimination method to solve the problem in ratio of ingredients in making brownies. Okay, we go for the next. Introduction of case study. So the situation is Hazim makes 3 different types of brownies which are matcha brownies, mocha brownies and red velvet brownies. These brownies contain 3 different ingredients for brownie footage with the following information below. Matcha, 7 cups of butter, 5 cups of brown sugar and 1 cups of flour. Mocha, 3 cups of butter, 2 cups of brown sugar and 2 cups of flour. Red velvet, 4 cups of butter, 3 cups of brown sugar and 3 cups of flour. After that, problem statement. Problem statement is about how many of each type of brownies can be made by a constant measurement of 3 different ingredients, which are 67 cups of butter, 48 cups of sugar, and 32 cups of flour.
The main purpose of study are to help Hazim find the total of each type of different kind of brownies that can be made by using a constant measurement of 3 different ingredients, to find the matrices from the linear equation in form of augmented matrix, and lastly to solve the matrix by using Gauss-Jordan elimination method.
Okay, next, we move to methodology. First step, we need to assume matcha brownies, mocha brownies and red velvet brownies as A, B and C. Okay, next, we come up with linear equation from the problem statement. Okay, for the first equation, we get 7A plus 3B plus 4C equal to 67. Next equation, we get 5A plus 2B plus 3C equal to 48. And the last one, we get A plus 2B plus 3C equal to 32. Okay. For the third step, we need to change the equation into the augmented matrix form. Okay, for the first row, we get 7, 3, 4, 67. For the second row, we get 5, 2, 3, 48. And the last row, we get 1, 2, 3, 32. As we know, for Gauss-Jordan elimination method, we need to solve the matrix until we get identity matrix at the end. From our matrix, we don't have leading one in the first column, so we need to exchange row 1 with row 3. And we get 1, 2, 3, 32 for the row 1, 5, 2, 3, 48 for the row 2, and 7, 3, 4, 67 for the row 3. After we get leading one in the first column, we identify that we don't have non-zero constant for the column 1. So the expression for row 2 is R2 minus 5R1 and we get 0, negative 8, negative 12 and negative 112. For the row 3, the expression is R3 minus 7R1. So we get 0, negative 11, negative 17 and negative 157. Next, for the column 2, we need to make leading 1. So the expression is R2 divided by negative 8 and we get 0, 1, 3 over 2 and 14. Next, we need to make non-zero constant for the column 2. So the expression is R1 minus 2R2 and we get 1004. And for row 3, R3 plus 11R2 and we get 0, 0, negative 1 over 2 and negative 3. Next, we need to make leading one in the column 3. So the expression is R3 divided by negative 1 over 2 and we get 0, 0, 1, 6 for the row 3. Next, we need to make non-zero constant in the column 3. So the expression is R2 minus 3 over 2 R3 and we get 0, 1, 0, 5. And finally, the final matrix we get is 1 0 0 4 for the row 1, 0 1 0 5 for the row 2, and 0 0 1 6 for the row 3. And we can conclude that A equal to 4, B equal to 5, and C equal to 6.
So, from the methodology, how much of each kind of brownies can be made by using constant measurement of ingredient. So A, which is matcha brownies, we got 4 brownies. B, mocha brownies, we got 5 brownies. And lastly, C, red velvet brownies, we got 6 brownies. From our discussion, we can find how much matcha brownies, mocha brownies, and red velvet brownies can be produced by using Gauss-Jordan elimination method. We can produce 4 matcha brownies, 5 mocha brownies, and 6 red velvet brownies from constant measurement, which are 67 cups of butter, 48 cups of brown sugar, and 32 cups of flour. It has been proven that we can estimate how many brownies can be produced for each type of brownies.
In conclusion, Gauss-Jordan method provides a systematic way to solve system of linear equation by transforming the augmented matrix into reduced row echelon form. This method may be applied into our daily basis of life.